In this video, I am solving 10 previous year questions of CSIR NET exam. See the first question. What is the next number in the sequence 2, 3, 4, 7, 6 and so on? This is the given sequence. 4 options given here. Now when you look at the sequence, there are 2 subsequences. The terms in the odd place, they are 2, 4, 6, 8, 10 and so on. The terms in the even place, that second term, fourth term, sixth term and so on, they are 3, 7, 11, 15 and so on. Here 3, 7, 11 adding 4 to each term, 11 plus 4, 15, then 15 plus 4, the next term will be 19. Fourth option is the answer. Second question, find the missing letter within this. See here, it is given here when you move column wise, A, leave one letter B, then C, leave one letter D, then E, leave the letter F, then G. The same will hold for this third column as well. Q, leave one letter R, then you will get S, leave T, U, then leave V, W. But for the second and fourth column, so it is moving backwards from bottom to the top. Y, next letter will be Z, leave it. Then once again go to the first letter A, then leave B, C, leave D, E. The same will apply here also. I, after I, J comes, leave that J, K. Leave L, M. Leave N, next will be O. Therefore, fourth option is the answer. See the third question. The area of a triangular park of dimension 50 meter, 120 meter and 130 meter is. 4 options given here. See, look at the dimension of that triangular park. One is 50 meter one side, another side is 120 meter, another side is 130 meter. Now these three numbers are nothing but Pythagorean triplets. So they satisfy the Pythagoras theorem. So therefore that triangular park is a right angled triangular park. So you have, for any right angled triangle, the largest side is hypotenuse. So this is 130. Then this is 50 and this is 120 meter. We need the area of that triangle. Area of the triangle is given by half into base into height. Half into base is 50 meter and height is 120 meter. So this gives you 3000 meter square. So first option is the answer. Fourth question, continue the sequence. This is the given sequence. Totally 6 terms are given. Next 3 terms we have to find out. Look at the terms of the sequence. Here 17, 28, 41 and so on. So here adding 3, then adding 5, here then adding 7. To get the next number, you have to add here 11, then here 13 and so on. So these are prime numbers. So after 13, next prime number would be 17. After 17, the next prime is 19. After 19, the next prime number is 23. Therefore, add 17 to 41. 41 plus 17, which is equal to 58. Then for 58, add 19, that is equal to 77. Then for that 77 add 23, you will get 100. Therefore, first option is the answer. See the fifth question. Binomial theorem in algebra gives 1 plus x whole power n equal to a naught plus a1x plus a2x square plus so on up to an x power n, where a1, a2, so on up to an, all these are constants depending on n. What is the sum of all these coefficients a0 plus a1 plus so on up to an? So for any binomial to the power n, we have nc0 a power n plus nc1 a power n minus 1 into b plus so on up to ncn b power n. where all these are called as binomial coefficients and they are denoted as C0, C1, C2, so on up to Cn. So there is a result, the sum of all binomial coefficients C2 plus so on up to Cn, which is equal to 2 to the power n. So this is a result which you have to remember from binomial theorem. Sum of all binomial coefficients is always equal to 2 to the power n. Therefore, the first option is the answer. See the sixth question. If A into B equal to 24, B into C equal to 32, C into D equal to 48, then you have to find out A into D. So the quick way to find A into D is writing A into D in terms of these given data. I'll write it as A into B cross C into D divided by B into C. That's because B into C, B into C cancels, you will get that A into D back. Substitute A into B is 24, into C into D is 48 divided by 32. This is equal to 8 3s are 8 4s are 12s are 36. 36 is nothing but it is a perfect square. Therefore, second option is the answer. See the seventh question. Find the missing number in this triangle, in the last triangle. So, three triangles given here. You have to get the relation between these numbers, numbers at the vertices and the numbers given in the triangle. So, the relation is, so this 90 is equal to the product of these three numbers, that is the difference between the product of these three numbers and the sum of these three numbers, that is 7 into 3 into 5 minus 7 plus 3 plus 5, which is equal to 21 into 5, this is 105 minus this 7 plus 3 10 plus 5 15, that gives you 90. So number within the triangle is equal to the difference between the product of the numbers and the sum of numbers at the vertices. So this is also same. The same logic applies for the third triangle. So 8 into 2 into 6 minus 8 plus 2 plus 6. So this gives you 96 minus this is 10 minus 16, 16, which is equal to 80. Therefore, fourth option is the answer. Eighth question. If all horses are donkeys, some donkeys are monkeys, and some monkeys are men, then which statement must be true? Four statements are given here. First, let us represent what is given in the question. All horses are donkeys. So, here horses, all these are donkeys. So, donkeys is a bigger set than the horses. Then some donkeys are monkeys. This is the set of all donkeys, out of which some are monkeys. Therefore, this is a set of monkeys which has a small region intersecting with donkeys, which says that some donkeys are monkeys and some monkeys are men. So, this is the set of all monkeys. Some monkeys are men. Small portion can be taken anywhere. So, here I will take it like this. This is men. So you can take it anywhere, but this is the most preferable one because from this diagram we can say which of the following statement is true. All donkeys are men. All donkeys are not men. So this is not true. Some donkeys may be men. See, some donkeys, this region represents some donkeys may be men. Therefore, this is correct. Some horses are men. No horse is men because horses, this region is included within this donkeys. This is not true. Last one, all horses are also monkeys. All horses are not monkeys. Only some donkeys are monkeys. Hence, all horses can't be monkeys. Therefore, only possibility for the statement to be true is the second option. Now ninth question, suppose, so these are the binary operation defined where addition, multiplication and subtraction, all these operations have the usual meaning. This delta is defined like this operation is defined, composition is defined like this, star and this is dot. So what is the value of, you have to evaluate this expression now. So 197, here it is composition, so apply this operation, that is 197 plus 315 whole square minus this delta is 197 plus minus 315 whole square, then the operation dot 197 star 315. So here it has to be like applied like this, 197 into 315 whole power minus 1. So this is a plus b whole square minus a minus b whole square. The answer after simplification is that is a plus b whole square minus a minus b whole square equal to 4ab. So 4 into a is 197 into b is 315. Then dot 197 into 315 whole inverse. Now you have to apply this dot operation for these two terms. This is now x, this is now y. X dot y is equal to, so 4 into 197 into 315. So x dot y is nothing but multiplying these two numbers into 197 into 315 whole power minus 1. So this a power minus 1 can be written as 1 by a. So this comes to the denominator, which is 4 into 197 into 315 divided into 1 by 197 into 315. So cancels, answer equal to 4. Now last question. Consider the set of numbers. The numbers are given here, 17 power 1, 17 square, 17 cube, so on up to 17 to the power 300. How many of these numbers end with the digit 3? So we have to get the power cycle of 7, the last digit of 7. 7 power 1 is 7, last digit is 7. 7 square last digit is 9. 7 cube last digit is 3, and 7 power 4 last digit is 1. 7 power 5 last digit is 7. Therefore, last digit of 7 repeats after every 4 cycle. Therefore, last digit of 7 has a frequency equal to 4. Once again, this is 7931, then again 7931, that repeats. So 7 power 6, 7 power 7, 7 power 8 and so on. Here it is given how many of these numbers end with the digit 3. That means from 1 to 10, 3 gets repeated 2 times. Therefore, up to 300 here, 300 divided by the frequency of the power cycle of 7, that is 4. 300 by 4, this gives you the answer 75. Therefore, there are 75 numbers within this set which end with the digit 3. So, second option is the answer. I hope you understood how to solve all these problems. Thank you for watching.